Have you ever wondered of doing routine data tasks like data import, export, backup using the power of Spark just by passing some arguments? Stay tuned. Dataproc Templates comes to the rescue. This is Balaji. I'm a cloud migration consultant with Google Cloud. In the era of serverless processing, running Spark jobs on dedicated clusters not only add process overhead but also take precious time from the developer. Using fully managed on-demand servers with Spark jobs helps developers focus on their core application logic and spend little or no time towards the framework. Google's Dataproc Serverless on Google Cloud Platform enables customers to run the Spark workloads without having to create or maintain the clusters. Dataproc Serverless will take care of all the necessary infrastructure in the background once the Spark workload parameters have been specified and the tasks has been submitted to the service. Dataproc templates are an effort to solve simple but large in-cloud data types including data import, export, backup, restore, and bulk API operations. The technology under the hood which makes this possible is the serverless Spark functionality based on Google Cloud's Dataproc. We have a collection of pre-implemented Dataproc templates as a reference and to provide easy customization for developers wanting to extend their workload functionality. Without having to create them from scratch, we can run typical use cases on Dataproc Serverless using Java and Python thanks to Dataproc templates. With the help of these templates, we can simply customize and run Spark workloads which are common. These Dataproc templates are written in Spark using Java, PySpark, and in Jupyter notebooks. These templates are customizable based on the requirements from the user. This offers the user with the power of Spark, and customizing for advanced use cases is super cool. These templates are ready to use Spark workloads and they can be configured by passing the required arguments and triggered as a Spark batch workloads. With these, further use cases can be extended and the development can be completed in no time. Here is the flow of data in the Dataproc templates. As the client submits the Dataproc templates with the required configuration and arguments, the CI/CD gets triggered and it does the complete Maven build with the required jars. Once the build is complete, the required jars are moved to the staging GCS folder. A batch job gets triggered in the Dataproc Serverless and it can be even monitored with the Dataproc UI. Once the batch job is started, the Dataproc Serverless looks into the job configuration and it starts the Spark session. Based on the input sources and the output sync, the data is read and written. For example, when the data source is high or pops up, the data is read from the high first and the required processing of data is done as per the written logic, and the processed data is written into the output sync specified in the template, may it be a BigQuery or GCS. Once all the workers gets their task completed, a notification is sent to shut down the Spark session and the whole batch job gets completed. The status of the above steps can be viewed either in the console as a step-by-step process or in the Dataproc UI screen. In case a detailed step-by-step status of workers are required, it can be viewed under the View Log section screen inside the batch job of the UI. Now, running these templates are super cool. It's a three-step process. First, clone the repository either in your local or in the cloud shell. Get into the repository and traverse to the Java or the Python folder. Second, obtain the authentication credentials with gcloud on where it is executed. It can be on your terminal or in your cloud shell, or it can be on your IDE console as well. Third step is to execute the template. Set the environmental variables required, then execute the template with the required arguments. The status can be monitored with the Dataproc UI. Here is the GitHub link for the Dataproc templates. The README shows the complete details. There are separate sections for various templates in Java, Python, and in notebooks. Each section has its separate README files and the various steps to execute those templates. In this section, we will cover hands-on on the Dataproc templates. Here is the Git page showing the details of the Dataproc template. In the README, it provides the required details. As already mentioned, the repository can be cloned in local or in the cloud shell from your data. There are separate sections for the templates using Spark in Java and in PySpark, and also using notebooks. Further, it mentions the basic steps to get started along with showing the flow of data in the template as well. Let's get into each section now. Here is the template written in Spark Java. It has a POM file which brings in the required dependencies during the execution of the templates. There are blog spots published in a Medium which shows complete details on these templates. It requires basically Java version 8 and Maven in order to proceed. These templates submit the job in the Dataproc Serverless using batch Spark submit. For execution of a template, the environmental variables needs to be set up like the project, the region, the GCS staging location and the subnet. Now let's take a look into the GCS to GCS template. Here is the input folder which contains the US state CSV file. Here is the output folder with no contents. Let's start with cloning the repository on the Cloud Shell. Then traverse into the Java folder. We can see the current branch with the Git status. Even the environmental variables are set up. Next, coming to the start script for running the GCS to GCS template. Here, the input file location, the output location and the project details needs to be passed as an argument. Once the job gets submitted, the entire process of build and jar creation and loading to staging location and submitting to a batch Dataproc Serverless is automated. After build, we can see the Dataproc Serverless triggered with the gcloud batch commands. Once the job gets completed, it clearly provides the details of the completed job. It can be monitored in the Dataproc UI as well. It shows the logs as well as the number of workers executed. If additional logs of workers are required, then within the batch job, it can be monitored in the view log section. This not only covers the logger information and errors, but also gives detailed worker level displays and notifications as well. Let's refresh the output of the GCS folder and see the output. You can see the file get copied into the output folder. Now let's get into the Python templates. It's similar to the Java templates. All the required dependencies and setup are mentioned in the requirements.txt. All needs to be done is create a virtual environment, activate it, install the requirements. Once this is complete, we need to set the environmental variables like the GCP project, region, staging location, and the start script has to be called along with the required templates along with the corresponding arguments. Here is the link for the execution of the templates from Jupyter Notebooks. Recently, Google made Spark even more powerful by enabling serverless interactive development through Dataproc sessions in Jupyter Notebooks. This enables a data scientist to automate the Dataproc template execution with Vertex AI pipelines and serverless Spark Kubernetes components as well. Here are the required screenshots for execution of the notebooks. With this, we are coming to an end for the demo of the Dataproc templates. We are happy to seek your feedback, queries and suggestions based on your requirements and usage of these templates. Please feel free to reach us at dataproc-templates-support-external@googlegroups.com. Thanks for watching and have a great day.